All right, the following solving or factorizing question, I'm actually going to do the B part of it before I do the A part. So that gives you a little bit of insight into why we're asking you to do the A part of the question. Okay, so this says determine A and B such that A plus BI all squared is equal to 5 minus 12i, and hence solve the equation z squared plus 4 minus 2i z plus 8i minus 2 equals 0. So this is quite a complicated looking quadratic. In fact, my coefficient of z is complex and my constant term is complex. So we're going to have to use a few of the tools that are in our toolbox to be able to solve this quadratic. We do notice that it's in the form ax squared plus bx plus c, so it is definitely a quadratic. So we've got z squared plus 4 minus 2i z plus 8i minus 2 equals 0. And just to make really clear, if you haven't been given it in the form where you've collected all your terms that have got z's and all your constants, you probably need to do that beforehand. In this case, a is 1, b is the whole of 4 minus 2i, and c is 8i minus 2. And I'm going to use my quadratic formula. Which you need to know off by heart. So negative b plus or minus the square root of b squared minus 4ac all over 2a. And I'm going to put my values in, so negative 4 minus 2i plus or minus the square root. This is going to end up being quite big. 4 minus 2i all squared minus 4 times 8i minus 2 all over 2. And I'm going to expand that, so negative 4 plus 2i plus or minus the square root of 16 to 8, 16i plus 4i squared minus 32i plus 8 all over 2, and we remember that I squared is negative 1. So we've got 16 minus 4 plus 8, so that's 20, and minus 16i minus 32i is minus 48i over 2, and I can take out a common 4 side of my square root. Over 2, and using my knowledge of surds, I can take that 4 out. So negative 4 plus 2i plus or minus 2 root 5 minus 12i over 2. And I notice I can factorize out a 2 from every single term. So 2 times negative 2 plus I plus or minus over 2. 2's can cancel, and this is what I'm left with so far. Now, I was asked to solve that equation. So when I get to this point over here, I can't actually go any further because I've got a complex number inside of a surd, that is not a perfect square. Even if I add my I-squareds on there, as we've done in the past, it's not going to give me a perfect square that's going to allow me to take that square root. So I need to use another technique. And what we do when we get to this part here is we're actually going to concentrate on what's inside of our square root and rewrite that as a perfect square. And this is what we're going to do. All right, so now we go to the A part. Determine A and B such that A plus BI all squared, because if I've got something that's all squared, I can take a square root, is equal to 5 minus 12i. Notice, it's the thing inside my square root. All right, so what I'm looking for is A plus BI all squared is equal to 5 minus 12i. And I'm going to expand my left-hand side. So I've got A squared plus 2ABI plus B squared I squared must equal 5 minus 12i. And of course, I squared is equal to -1. So A squared minus B squared plus 2ABI is equal to 5 minus 12i. Notice I have a real component over here and a real component here, and I have an imaginary component and an imaginary component. So I can equate my real and imaginary components. So I can say therefore A squared minus B squared is equal to 5, and I can say that 2AB is equal to -12. This can be equation 1, and before I give equation to a number, I'm going to rearrange it so that A is going to be -6 over B. All right, and I'm now going to substitute equation 2 into equation 1. So I have -6 over B all squared minus B squared equals 5. And that gives me 36 over B squared minus B squared equals 5. If I multiply every single term by B squared, I'll get 36 minus B to the 4 is equal to 5B squared. And I notice that can be rewritten as a quadratic. So I've got 0 is B to the 4 plus 5B squared minus 36. And if you're not comfortable factorizing that, we can just let B squared equal K, and that gives me that K squared plus 5K minus 36 equals 0. And 9 and 4 works. So K, 9 and 4 must be plus 9 minus 4. So by the null factor law, K is equal to 9, or K is equal to 4. Okay. But B squared equals K, so we've got that B squared is equal to -9, or B squared is equal to 4. Our original question says that we need to find A plus BI all squared. Now this A and this B are both real numbers. Okay, so B can't be a complex number. So B is a real number. So B is an element of the real numbers. So we're going to discard this side. And that leaves me with B is equal to plus or minus 2. Now I'm just going to shrink this because I've obviously written it too big to be able to fit in this side. Move it up and we'll shrink it a little bit. All right. Now, if I've got 2 values for B, that means I'm going to have 2 values for A. So I'm going to have to work it out. So when B is equal to 2, and we're going to use equation 2, so A will be negative 6 over B. So A will be negative 3. And when B is equal to negative 2, A is going to be equal to 3. So what we've got is that A is equal to plus or minus 3, and B is going to be equal to minus or plus 2. So if you write it like this, basically the plus, the signs on the top belong with the first group of answers, and the signs on the bottom belong with the second group of answers. Okay, where am I going with this? So now I can say, well, therefore, 5 minus 12i can be rewritten as plus or minus 3 minus plus 2i all squared. Now that looks really funny, okay? But if I take a plus and a minus outside of this, so 5 minus 12i, if I just take a plus and a minus outside of my bracket to simplify things, okay, if I keep my positive 3 there, if I multiply the plus in, I get a plus 3. If I multiply the minus, I get a minus 3, so that's okay. If I take this plus minus outside of my 2i, I'm going to need the opposite sign, so that when I multiply a plus in, I get a minus. When I multiply a minus in, I get a plus. And of course, if I square anything, I'm going to end up with a positive. So if I'm going to square this plus or minus, it's actually going to end up as a positive anyway. Okay, so 5 minus 12i is just going to be 3 minus 2i all squared. And this is where I'm actually going to use it in my original equation. Okay, so this is a rewriting or a rewording of that. So I can say, therefore, Z is going to look like this now. Minus 2 plus I plus or minus the square root of 3 minus 2i all squared. And if I square root a squared sign, all I get is Z is negative 2 plus I plus or minus 2i. And then I can very nicely say Z has to equal minus 2 plus I plus 3 minus 2i, which is going to be 1 minus I, or Z is going to be minus 2 plus I minus 3 minus 2i, which gives me negative 2 plus I minus 3 plus 2i, and that's going to be negative 5 plus 3i.